Hello, how you doing? It's Mr. Do the Math, and today we're going to talk about rational exponents, right? Rational exponents. So, when you hear the word rational, what comes to mind? What does rational mean? What do you think of? Reasonable? Okay, mathematically, what do you think of? Ratio. When you hear a ratio, what do you think of? A number, what did you say, a number over a number?
Yeah.
What's the number over a number called?
Fraction.
A fraction, yeah, good. So, right. Rational, same as fractions, right? So when you, fractions, if I can spell it, fractions, right? So that goes in that first line. When you think of rational, you think of fractions, right? And so look, we're going to talk about the definition of rational exponents. Rational exponents, right? That's what the focus is today. Rational exponents. So the definition is this. The definition is this. If you have the nth root of b to the m power, right? N being, I'm giving you the definition. N being an index number and m being an exponent, right? You could rewrite this radical to look like this. B to the exponent over the index number. Okay? All right, this is what I'm saying. If I, for instance, had, say, the third root of x to the second power, right? If I had the third root of x to the second power, this would be the same as x to 2 over 3, right? So the index number is always in the denominator of the rational exponent, all right? So everybody with me so far, okay? All right, so rational exponents allow us to perform math that is not possible using radicals. All right. So in order for us, like we can't technically multiply radicals that don't match, right? If their index don't match, you can't do anything with it. So we have to change them to rational exponents to be able to operate on them, right? Or to do the math, right? And so that's what we're going to be doing today. Okay. So for instance, when we look at, say, like the fourth root of 9, right? If we look at the fourth root of 9, okay? And this is going to be an overarching thing that we're going to be doing all day today. So the fourth root of 9, right? It could be rewritten, like the first thing you want to do when you rewrite this is you want to break down this 9, right? So most numbers, or there will be some numbers that are a bunch of the same number. So 9 is a bunch of what? 3s, right? So you have 2 3s in there, right? You have 2 3s in there, right? And so one thing we didn't talk about when we was doing like the factorization, when we have the same number over and over again, we just give that number an exponent. So if we have 2 3s, we give it an exponent. What would this exponent be? 2, right? So this is the same as the fourth root of 3 to the second power, right? Now, let's write this as a rational exponent, right? What would that be? Can somebody talk me through it? Yeah, go ahead, Morgan.
Is it
3?
Yeah, 3 over 2 to the 4th.
2 fourths, right? 3 to the 2 fourths, right? Now, from here, you want to simplify, right? What would that simplify to be? 1/2, right? So it's 3 to the 1/2 power, right? 3 to the 1/2 power. Okay? Right? And so that's what that is, simplify. And then like we can rewrite the 1/2 to be 1/2 as a radical is just the square root of 3. Okay? So just so we know, if it's to the third power, it's 1/3. If it's to the fourth power, it's 1/4. Fifth power, 1/5, right? And if it's just blank, it's 1/2. It's the 1/2 power, right? These are the associated powers. All right? Okay. Now, let's look at number 1, right? Express the simplest rational exponent form. Express the simplest rational exponent form, right? So when they say simplest rational exponent form, what we're going to be doing is we're going to be leaving from here and going there, all right? And so the first thing you want to do, the first thing you want to consider, right? Let's create some steps. The first thing you want to consider is simplify the number. Simplify the number, right? So basically you want to find groups, right? I don't want to say pairs because pairs mean two, right? You want to find your pairs, your trios, your quads. You want to find your groups, right? So you want to find your groups with the numbers. Then the second thing you want to do is you want to write the new exponent, right? When you write the exponent, finally what you want to do is you want to simplify the exponent, right? Right? Simplify, reduce the fraction, right? So let's look at number one. Number one says the square root of 6x to the 7th power. The square root of 6x to the 7th power, right? Now again, if it's the square root, that means that the fraction is 1/2, right? So what we're going to do is we're going to give everybody that 1/2 fraction. So that means it's going to be 6 to the 1/2 power, and then it's going to be 7 times 1/2, right? What's 7 times 1/2? I mean, yeah, but we're going to keep it as a fraction. We can keep it an improper fraction. So it'll be what? 7 over 2, right? So 6 to the 1/2 power times x to the 7 over 2, right? So that's that, right? So we put everything over the index, okay? Let's look at number 2. Number 2, you got the 4th root of 9, ab to the 6th, c to the 3rd, d to the 12th, okay? So again, the first thing you want to do is you want to simplify your numbers. 9 is what? 3s, right? You got 2 3s here, okay? You got 2 3s here. So we got 3 squared in here. We got the a, the b to the 6th, c to the 3rd, d to the 12th, right? Now from here, you want to write out the exponents. So you want to put all of these over 4. So that'll be 3, 2 over 4, a, 1 over 4, b, 6 over 4, c, 3 over 4, and d, 12 over 4. Right? So we wrote out the exponent, and then finally we're going to simplify the exponent. Which of these exponents can be simplified? Which ones? Talk to me.
3.
The 3 can be simplified. What else can be simplified? The b and the d. Right? So 2 over 4 is the same as what? Half, right? So it'll be 3 to the 1/2, a to the 1/4. 6 over 4 can be simplified to be what? Absolutely. So that's b to the 3/2, c to the 3/4, and then 12 over 4 is 3, right? There we go. So this is in rational exponent form, right? That's it. So we simplified the number, we wrote out the exponent, then we simplified the exponent, right? That's your steps, okay? Now let's go to simplest radical form, right? In radical form, we want to, we're going to go from here back to there. So we got 5 to the 1/3 power. 5 to the 1/3 power. 1/3 is the same as cube root. So we would just say the cube root of 5. Right? That was really nice. Okay? Number 4 though, you got 8 to the 1/6 power. Okay? So for simplest radical form, you do the same thing as you do in rational form. First thing you want to do is you want to break down a number. All right? What do we have in 8?
4 and 2.
Huh? 4 and 2. And then what? 2 and 2. So how many 2s do we have?
3.
Right, so it's 2 and 4, and then that's 2 and 2. So 8 is the same as 2 to the 3rd power. Okay? So we simplify our number by finding its groups, and then we're going to write out the exponent. So then that's going to be 3 times 1/6, which would be 2 to the 3 over 6, which can be simplified to be what? 1/2, yeah. So it'll be 2 to the 1/2 power. Now, the goal is to make it in simplest radical form. So then, now write 2 to the 1/2 as a radical. Yes, ma'am. Square root of 2, right? That's that. Okay? So again, simplify, write the exponent, and then you simplify the exponent, and then for a radical form, you write it out the new radical. Okay? Alright, let's look at number 5. Huh? You said 3 steps. Do you say it's a lot of steps?
Some of them.
Okay. Yeah, I mean, yeah. Y'all have number 5? I got one for you then.
Oh, yeah, we do.
Okay. So it's x to the, is that 5 over 4?
Yeah.
Y to the 1/2, I thought you said your hand on number 5.
Yeah, we do.
Z to the 3 over 4. Okay? Now, to write this one in simplest radical form, right? To write this one in simplest radical form, which means that they all got to be under the same radical, the denominators must be the same, right? So you got to find common denominator. Find a common denominator. So what's the common denominator between these 3 exponents? 4 is. How would I get the 4 here? Absolutely. You multiply the top and bottom by 2. So then we end up with x to the 5/4. Yeah, I'm recording, bro. What is it? Alright, thank you. Y to the 2 over 4, Z to the 3 over 4. Okay? Okay? So now these are all the same. So now since the denominators are all the same, we can write out our radical now. What would our radical be? Huh? The 4th root of what? X, Y, and Z? What's our exponents? X, 5, 2, and 3. Right. Okay. It's not so bad, right? Okay. Alright, so now let's look at simplifying because we're about to start doing some mathy math. Alright? About to start doing some mathy math. That's a warm up. Alright? That's a warm up. Alright, so here we go. Let's look at number 6. We got m to the negative 1/2 power. Right? We got m to the negative 1/2 power. So we're going to simplify this. Right? Alright, so m to the negative 1/2 power, how do we get, we can't have negative exponents, remember that, right? So how do we undo this negative exponent? What do we do? Yeah, move it to the bottom, alright? So it'll be 1 over m to the 1/2 power, okay? Now, here's the thing. In denominators you can't have fractional exponents, right? Because a fractional exponent is the same as a radical. Right? So you can't have fractional exponents. So what do I need to do to get rid of this fraction? Huh? Times it by 2. Right. So this would be m2. Right? Well, now you can't times it by 2 because like you would have to raise it to the second power. So but we do want it to get 2 over 2, right? So what would we multiply these, what would we multiply the m's by? M to the what power? 1/2, right? So we need 2 at the top, right? And then whatever we do at the top, bottom we got to do at the top, okay? So now what ends up happening is the m to the 1/2 times m to the 1/2 is actually m to the 1 over 2 plus 1 over 2, which gives us our 2 over 2, which is our 1, right? Does everybody see that? This is this, okay? And then this stays what it is. So you end up with m to the 1 over 2 all over m. All right, so then tell me this. What if I rewrote this to be like this? So I had m to the 1/2. What if I did m 1 over m, the square root of m? What would you do? What would you do here? Multiply by the square root of m. right? Alright, that look better?
Yeah.
So then you end up with the square root of m over m squared, which is m. Right? Alright, let's do it. Square root of m over m, right? Alright, so then from here, you can change this to a rational exponent. So the square root of m is the same as m to the 1/2 power. So it would be m to the 1/2 power over m. Right? So it's two ways to do it, right? It's two ways to look at it. So if this looks too like fuzzy, you can go back to what's familiar, right? Because these are the same numbers, right? And then you can simplify at the end, okay? All right, let's look at this one. Number 7. You got x to the negative 7 over 5. X to the negative 7 over 5, okay? X to the negative 7 over 5. First thing we got to do is we got to put in the denominator. So it's x to the 7 over 5 power, right? Again, the goal is to get rid of the whole number, right? Or to get rid of the radical, right? So in this case, think about it like this. How will we get this to be a whole number? What will we have to make this the top number? 7 would have to be what to get it to cancel? What's the next multiple of 5? 10. So we would have to add what to 7 to get 10? 3, right? So that'd be x times 3 to the 5th power. 3 over 5, right? So then that's whatever we do at the bottom, we got to do at the top, right? So then what we end up with here is 7 over 5 plus 3 over 5, which gives me 10 over 5. And then at the top is 3 over 5. 3 over 5, right? So 10 over 5 simplifies to be what? 2. So you get x 3 over 5 over x squared. Okay? Okay? So again, in the denominator, we gotta get whole numbers there. We gotta have whole numbers there.